Exploring Material Science, Climate Change by Kate. The material I chose is green concrete. Concrete itself is used to construct many aspects of society, cities, dams, and monuments. It is used for its durability, strength, and versatility. However, the production of cement is responsible for roughly 8% of worldwide carbon emissions, and looking at the current rate of construction, by 2060, the number of buildings would have doubled. It requires a great amount of energy to heat up the material and produce concrete using cement. Green concrete is a form of eco-friendly concrete that releases less carbon emissions, uses recycled industrial waste, and is cheap and durable. It is specifically developed by the country Novacem, a carbon dioxide absorbing concrete that uses magnesium sulfate instead of limestone. Its properties include it has a high strength between 20 and 40 MPa, it's very durable and can withstand extreme environments. It becomes denser as the ratio in the water in the concrete mixture decreases. It's not reactive. It is a solid state of matter and it has low conductivity. These properties make this concrete a great option for construction because it is able to form buildings that last hundreds of years and can withstand most environmental conditions. Its carbon dioxide eating nature is good for greenhouse gas emissions and can help slow climate change. The chemical structure of this concrete. As you can see in the diagram to the right, the one on top is roughly the structure of normal concrete, because the structure of this green concrete hasn't exactly been released on the internet, but you can imagine that it's similar. And the diagram on the right also has the process of creating this green concrete. As you can see, it uses magnesium and calcium, oxygen, silica, and iron, and it has many processes in order to form the cement at the very end. So the cement is based on magnesium oxide, MgO, and hydrogen magnesium carbonates. It uses accelerated carbonation of magnesium silicates under elevated levels of temperature and pressure. It absorbs large amounts of CO2 when hardening. It uses magnesium silicates, which emit no CO2 when heated, and its production process also runs at lower temperatures, around 650 Celsius, and after production, the total CO2 emissions are around 0.5 tons of CO2 per ton of cement produced. But however, the Novacem cement formula absorbs far more CO2 as it hardens, 1.1 tons. So the overall carbon footprint is negative and removes 0.6 tons of carbon per ton of cement. The elements of magnesium, carbon, oxygen, iron, silicon, hydrogen, and chlorine are all used in the process to make this cement, and covalent bonds are used. Molecular behavior. Concrete has both polar and nonpolar parts in its composition, making some parts hydrophilic and some parts hydrophobic. Experts still can't figure out whether the molecular structure of concrete is comprised of continual bonds found in stone and metal, or a sea of aggregate particle clumps bonded by CH. Due to its need to be durable and strong, concrete has dipole-to-dipole forces which are considerably stronger than some of the other intermolecular forces. Thank you for listening to the presentation about material sciences.